Hello all. I have covered so far all the basics of deep learning using the PyTorch. If you have missed the previous videos, I strongly recommend you to go through all the basics videos first before starting with this video. In this video, I'm going to talk about the linear regression. So this is our first project here in this playlist. So as usual, let's jump into our Colab notebook and let's start with this one. And let's understand what are all the models that we do have. So ML models, right? So we have linear regression. We have random forest. We do have logistic regressions, and we do have KNNs, etc. So in this video, we are going to use this linear regression ML models. So when we have to use a linear regression and when we have to use a random forest. So in this video, let's focus on the linear regression. So whenever you see a linearity between x and y, for example, let's quickly check linear regression, right? So this is a simple graph of linear regression. So this is the x and this is the y. If in case whenever the x value changes, if the y value is also changing, that is in those scenarios, whenever there is a linearity, you have to use the linear regressions. And in rest of the other videos, we will cover about the random forest and the logistic regressions. Let's focus on the linear regression now. S- So let's jump back into so when in which all the scenarios we have to use the linear regression. So whenever you are predicting numerical values, numerical continuous values. For example, what are exactly those? Like predicting house prices, or prediction of employee salary, or prediction of car service cost, or prediction of insurance cost. So in those features, I mean, in those scenarios, we can use the linear regressions. And also, whenever the features are less, it's always recommended to go with the linear regression. For example, if you're predicting the house price, so what are all could be the inputs? So we might have country, state, city, number of bedrooms, um, square feet area, and parking available, number of floors, etc. So whenever we look into these features and what exactly these are the features, and the output that we are going to predict is these are the features. Features are nothing but inputs, and labels, they are nothing but outputs. Nothing but outputs. So what is our output here? As usual, price of the house, right? Cool. Let's jump into back the linear regression model. So for the data purpose, I'm going to consider a straight linear curve like this one, and then we will see. And then what we will do, so after having a linear regression curve like this one, I'm going to use some random values. The random value can be anywhere here or over here, and then we will train the model with this data, and then we will adjust this random value to match with the actual values. So let's see how it's going to do. So for the linear regression, the formula is y is equal to a plus bx, or you may say like y is equal to um, m mx plus c. This is something that you might have seen regular most of the times. So let's talk about the a plus bx. So where a is equal to the bias here, and the b is equal to the bias is nothing but this one. So the length from here to here is the bias. B is equal to weight. Okay, so let's start with our PyTorch. So import torch. Okay, and then what, we need some other libraries as well that we will import the rest of the video. So I'm going to have a weight is equal to 0.7. I'm taking a random values, and bias is equal to 0.3. Okay, so let's calculate the x value. So torch dot arrange, you know what this does. Start is equal to 0, end is equal to 1, step is equal to 0.02. So basically this is how x looks like. If in case if you want to see, you can see these values over here. Okay, so I would like to have a two-dimensional tensor. So, and also I would like to consider all of these as the features. So I'm going to add one more dimension, unsqueeze. Dimension is equal to 1. Now let's see how the x looks like. Okay, and let's go back to here and let's see. So the formula we already have, y is equal to bias a. So it's mentioned like a plus b x. So and b is the weight into the x value over here. So this is done. So let's look at x first 5 values, and let's look at y 5 values. Okay, so so far we are good. So and let's see like how many values we do have. Length of x, length of y. This is very much important because we should know like how many values are there. So we have 50 values over here, and I have used this y is equal to ax plus b, the linear regression formula. So basically the output, if you look at the output obviously it looks like a linear curve. So 50-50. So basically what we have to do in the ml model, so we should have some training data where we train our model, and to test whether a model is working fine or not, so we use the test data to test our model. So in our case we have like 50-50 variables. I would like to split this data. So the training data, let's train the model with 40 records, and let's test the model with rest of the other 10 records. So for this what I'm going to do, let's have one variable called split data is equal to, so I want 80% of these variables as a training one. So length of x. So I mean this can be a float number as well. So for the safe side, let it be like int. So split data. So 40%, 80% of so 50 into 0.8 is equal to how much? 40, right? So 40 times 40 samples I have sent to the split data. Now so far we haven't split the data. Let's split the data, right? So x train comma y train is equal to x of split data. So like first 40 values, and y of split data, and x test comma y test is equal to x of split data, this one rest, and y of so many typos, sorry for that, this one. So there are other models as well. If in case if you're comfortable with the machine learning, you might have seen the models like train test split as well that we can use, but for now I'm using this one. So after this one it's always important to test to check like the length of each values. So 40-40, x train is 40, y train is 40. Length of x test, length of y test. So this is fine. So we have training data for 40 samples, and we have the test data for 10 samples. And now let's see. So no matter how much we do, we humans, we visually want to see like how it looks like. So let's import matplotlib.pyplot as plot, one of the libraries for in the Pythons to see our data visually. So I'm writing a function, plot predictions. So I would like to have four features: train data, right? So I would like to pass the data itself here, x train. Train labels is equal to y train. So test data is equal to x test. Test labels is equal to y test. So I mean, let's also have, I mean, once after we do the predictions, I'm going to pass the parameter here, but we will use in the later. So because if you see, look at the data, it's all like the numerical value. So I'm going to use the scatter plot. So plot dot scatter. So let's look at the training data, the train data. So instead of writing x10 and y train, I'm going to use the values over here. Train data, comma, test data. I would like to color have like blue, black. Black means K, so blue means B. Label is equal to training data. Right. Let's see how this looks like. Right. And then, so I'm calling this function here plot predictions. Sorry, train data, train labels. See, I already made a first mistake. So you can see this is how the training data looks like. Let's see our test data. Plot dot scatter. Test data, test labels. So basically, it's like x test and y test. Color is equal to green. Let's see. Label is equal to testing data. Nice. So we have seen, see, this is a linear curve, linear straight line. So basically, this is our training data, and this is our test data so far, right? So and also, I mean, in the next 5 minutes, I'm going to use some random values, and whenever we generate a random value, the random value may come here or may come here, may come here, and we are not sure. So I mean, let's. It's better to write a code now itself for the predictions, but anyways right now we don't have any predictions, so it's fine. So if predictions is not none, it's like simple English. Okay, it's not now. Right now we have a given test none instead of. So now if we have the predictions, I would like to have like test data and predictions. Color is equal to red. Label is equal to predictions. Nice. So right now predictions, because we have SN predictions as none, so nothing we can see for the predictions. And now which color is what? So it's better plot dot legend. So if in case if you wanna give some mm, property, we can give it here like this. Something I'm going to give it like some 18. This optional and okay, okay, let's do this one. Okay. Okay, so let's do this one. Plot dot legend. Let it be. Let's see. Okay, so plot dot legend location is equal to 1.02 comma 0. So basically, let's see how this generates. Interesting. Okay, so what I did over here, so I did like plot dot legend. So if in case if we don't give the parameter over here, so let's see what happens. The legend actually it is over here, but I want, I mean, sometimes if we have the random value over here, it looks like a mess. So basically I'm going to give the location of this one to be like 1.02. So here and at the base, right? So okay, now it's fine. So we can see, and also let's give the title plot dot title linear regression curve without predictions, right? So we have completed our the first linear regression. This is, I mean, we haven't worked on the model, just we took that dummy data and we have created a linear regression curve. Let's build a model. Okay, as I said, I'm going to use the linear regression. So I mean, let's write the code like a expert instead of like a beginner. So let's directly jump into the classes. If in case if you are not comfortable with the classes, it's totally fine. I'm going to explain you here, I mean, how to use the classes. So again, I'm importing the libraries. um, so from torch, so we have to use this module called nn. So it's a neural networks. Right. So first, I mean, this is the first time I guess in our entire tutorials we started about the neural networks. So let's take a class. I'm naming the class as linear regression model. Okay. So ideally in the class you can write the class directly itself. But if in case if there is already a class and if you would like to use that class parameters over here, so you can pass those class value here. As we already have imported the nn over here, so I'm importing that nn module here. Okay. So let's write a function definition in it. Okay, self. So we have to pass, I mean, whenever you write, whenever you're initiating a function over here, the self is the first one that you have to write. Instead of self, you can write your name as well. For example, Rajiv or like X or 10, not 10 numeric one, like any name that you can pass, any string we can pass it over here. For now, I'm just going with the, as per the tutorials, I'm just mentioning it as self. And then so I wanted this to be super dot init of this one. So you have to remember this one. But once you go to the classes of classes, so basically you get familiar, you understand like what is why we have to mention the super over here. Because we are getting the parameter, we are importing this class, and we are making our class as super, right? So in linear regression, so what do we have? Linear regression, y is equal to a plus bx. A is the so a is equal to bias, b is equal to weight, right? And so x is the input, x is equal to input, right? Basically y shows predictions, right? So now here, so we need first let's take the weight. So whatever you're calling over here, so you always have to consider self here going forward. So self dot weight is equal to nn dot parameter. Okay. So as I said, let's take some random variable. So what data I'm going to pass is a random variable. For example, if you see something like toss dot rand of 1, so basically it generates one random variable. You can see, okay, 0.1209. Okay, so this is like the normal a regular value. So we can also have this rand, and this is a normal value, normalization value. So this is the value. So basically, what is the difference between the normalization? So basically, what normalization does is that if x is the value, x is the random value, okay, then normalized x is equal x is normalized x is equal to x minus average average by standard deviation. This is how the normalization is calculated. So I'm going to give like toss dot rand n. I want one value over here. So you can requires grad is equal to false by default. This is always false. So I don't want to have this one. So I would like to show it over here. And then data type data type is equal to toss dot float 32, right? So we have initialized the weight, and also now we have to go with the bias self dot bias is equal to nn dot parameter toss dot again one random value 1 request grad. I mean, if in case I'm just mentioning it over here for your information, but now anyways I'm commenting this. Okay, data type is equal to toss dot float 32. So this is something that we already have covered in one of our basic videos. So go through it. And now, whenever we have to pass the x, we need some function. So that's the reason I'm using one more function, forward. Or also, like simple terms, just do remember that whenever you're writing the class for in the deep learning, always we should have a class called forward. So again, I have to be like self. I would like to pass over here x, and I mean this one, this torch. I mean what I'm going to write this torch dot tensor. This is an optional one. Basically, I'm expecting the output as torch dot tensor, so I'm mentioning torch dot tensor. And also, if you see over here, this torch dot tensor, the T starts with a capital letter. So far we have seen. I mean, whenever we're creating the random tensor, is equal to torch dot tensor of 1 comma 2 comma 3 2 comma 3 comma 4, print random tensor, right? So the here we have used the small letters, and here I'm using the capital letter. So basically, the difference is that whenever you're creating the tensors, you have to use this one, and whenever you're using the tensors inside a class, and when you're declaring a variable, so you have to use toss dot tensor. Just remember that. So this function I would like to return y is equal to ax plus b. So y is self dot bias plus self dot weight, right, into, I would like to pass the x over here. Huh. We have written our first class over here for the linear regression. This is this is going so good so far. Nice. And then let's see how what are the next steps. Okay. So now this class, I'm going to consider this as a our model. Okay. So I'm taking our model 0, naming it as model 0. So linear regression model, right? Now, as like I said, we have given one random variable over here. Let's see what is that variable. So you can use like model 0 dot parameters to see, and this is generating a generator. So let's convert into a list of this one. Hmm. So parameter containing a tensor this one and a tensor this one. So this is not clear. So basically, rather than this one, let's use a the dictionary format. Okay, so the weight is 0.6788 and the bias is 0. Okay, this is what it has generated. Okay, a random variable. This is not we have given. And what is our original weight that we have given in the earlier? So it is zero point 0.7 and zero point 0.3. So this is so close, but sometimes it might not be close. Sometimes it is like a random value. So now we have our X train, which we already did we here, and we have Y test. So basically, and now we already have our model here. So let's do this one. So what we can do, y predictions is equal to model 0 of X test. So what exactly is this one? So we have our model, and then for the test data, we are going to do the predictions. So we can use this one. So basically, the problem with this one is that this works fine if we use this one. The problem is that there is something called gradients. The gradients are included in this one. So basically, whenever we are predicting the values, we don't want the gradients to be there. We want the gradients to be there only whenever we are training the model, and here we are predicting. So we don't want this one. So I mean, so whenever you're dealing with large, huge data sets, where now we have like only 50 samples of data. So to increase your computational speed, so always use this torch dot inference mode. There is one more called zero no grad as well. You can use that as this well, but I do recommend you using this one. Y predictions is equal to model of 0 x test, right? And y preds of 5. So these are the first 5 values, and let's see what are the original values. Y test of 5. Okay, so the first value, the prediction is 0.440, and the here the original value is 0.866. Okay, let's see visually. So we already have this plot predictions function, right? So if you go back to all the way up here, we have this um, the function over here, the predictions, we have passed nothing here. So let's pass the predictions here is equal to vibrates, right? Hmm. Okay. Congratulations. I mean, we have completed our first model, but you can see here, this is the actual data and this is our predictions data. So it is like far from the predictions. So basically what we have to do, we have to find a way on to reduce the distance between here and here, and then ideally these red dots should be on top of the green dots. Then we have achieved like 100% of accuracy. Let's see how we can achieve in our upcoming videos. Keep watching my videos and please do subscribe if you haven't done so far. Thank you.